5.1 Gravity. In this lesson, we will explain what gravity is, calculate how much gravity there is, attract and repel. When two objects, there's a force that wants them to come together, that's attract. When they move away, that's repel. Gravity is a force. Anytime we have two objects, each one has mass, they are going to attract each other. So there's a force, and that force is gravity. Okay. So when we drop an apple, the apple falls to the ground because the apple and the earth are attracted to each other. Gravity force. So in this picture, we know that the bird and the girl will attract each other. We know that for example, the girl and the tree will attract each other, for example. So everything will attract each other. But actually, the girl is most attracted to the earth. That's why the girl is always has a force pointing downwards towards the earth and not towards the tree. It's not that way, for example. It's not pointed towards the tree. It's pointed towards the earth. Why? Well, because the earth has more mass than the tree or the bird. So what did we learn? The girl is attracted more to the tree, to the earth than to the tree, because the earth has more mass. So the big idea number one, well, more mass, more gravitational force, more gravity. Next question. Is the boy attracted more to the earth or to the sun? Well, the sun is actually much bigger than the earth, but the boy is attracted more to the earth. We are stuck to the earth, not to the sun. Why? Because the earth is closer to the boy. Distance is smaller. So big idea two. Greater distance, smaller force. As distance increases, force decreases. So here's a summary of big ideas. Two objects with mass will attract. This attractive force is called gravity. More mass, more gravity. More distance, less gravity. There's a formula for this. It's G m1 m2 divided by r or d for distance between the two objects. Okay. G is called the gravitational constant. If we Google it, gravitational constant is about 6.67 times 10 to the negative 11. Okay. And it's Newton times meter squared divided by kilogram squared. What does that mean? We'll figure it out in a bit. M1 and M2 are masses of the objects. D is the distance. What does this times 10 to negative 11 even mean? Well, for big numbers, sometimes when we have really big or really small numbers in science, we like to use scientific notation. For example, this one, I count 7 zeros, so this is 6 times 10 to the 7. So this one will be 6.32 times 10 to the 7th. The next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 7 times 10 to the 13. So this one will be 7.18 times 10 to the 13. Okay. We can also go the other direction. So 5 times 10 to the 7 is just 5, followed by 7 zeros. Every 3 zeros we can add a comma. In the US, we use commas. So 5.1 is just 51. It's very similar. Okay. Yeah. For this one, if we want to do this one, we could just plug this into Google and see. We get 204 followed by 6 zeros. Okay. For small numbers, it's actually 10 to the negative power because negative exponent is division. Division makes it smaller. There are 6 zeros here, so I know it's 3 times 10 to the negative 6. So this will be 3.2 times 10 to the negative 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 to the negative 11. Oops. Negative 11. So that's going to be 8.46 times 10 to the negative 11. Well, 3 times 10 to the negative 5, well, it'll be 0.0000. There are 5 zeros. That means this one will be 0.000034. Okay. So that means that this number is actually very, very small. 0.000, there should be 11 zeros, including a 0 at the beginning. That's how big it is. These units allow us to convert to newtons. So here's an example. Mass 1 is 4 kilograms, mass 2 is 10 kilograms, distance is 2 meters. Okay. So we'll just write G for now. 4 kilograms, 10 kilograms divided by 2 meters squared. That's going to be 10 kilograms squared divided by meters squared times G. Yeah. We could plug in G. That's actually fine for class. That's the force. If we plug in G, that's 10 times kilograms squared divided by meters squared times 6.67 times 10 to the negative 11. And this is newtons divided by kilograms squared times meters squared. That way the units cancel and we get newtons at the end. And we get 6.7 times 10 to the negative 10 newtons. Oops. 10 newtons. But really, you can just answer like this. One more. This time the mass is 4 and 20. So the force is going to be Gm1, M2 divided by d squared. That's going to be G times 4 times 20 divided by 2 squared. That's going to be 20G. Just no units for now. Notice that in the first question, we have 4, 10, so the masses are greater. What happens to the force is 10G. For this one, this is 20, the force is 20G. So the two examples show that when mass increases, the gravitational force also increases. Okay. That's it for this video.